All right, guys, I wanted to go over your Romanov extra credit just to make sure you guys understand these problems for your exam. So remember, when you're doing these, you have to put the sex chromosomes. You have to designate whether someone's male or female. So first, if you are female, you would have 2 X's. And if you're male, you'd have an X and a Y. Secondly, if the boxes are not filled in or the circles are not filled in, that person does not show the trait. So they can't fully have the recessive trait of hemophilia. So here, Alexi is the only person who actually has hemophilia. So we can start with him because he actually has it. Remember, these are sex-linked on the X chromosome. And so because males only have 1 X, nothing's going to go on the Y. So he's going to have XY to be male, and his 1 H will be recessive so that he fully has the disease of hemophilia. We can then work backwards to figure out everybody else's genotype. He had to get his recessive H from one of his parents. When we look at his father, Tsar Nicholas does not have the disease, therefore his H must be dominant. But that means his mother, who does not have the disease, must be heterozygous. She must have a dominant to make her healthy, but she's carrying a hidden recessive that she then passed down to Alexi. This means that all of the daughters are either fully dominant and do not have the disease at all because they got a dominant from mom and a dominant from dad, or they're like their mom and they got the dominant from dad, but they're carrying the recessive H from mom. When we look at Grandpa Alexander, he also does not have the disease, so he would have a dominant H. When we look at Grandma Maria, she does not have the disease, so she could either be fully dominant or she could be heterozygous. We cannot tell which one she is just from this information. So the genotypes of Maria, as I just said, she could basically either be fully dominant or she could be a carrier like her son's wife was. So I want to go down here now and talk about number 2. So we have figured out that Alexandra's genotype must be heterozygous because she does not have the disease, but she is hiding that recessive H that she passed down to her son. Another term for this heterozygous genotype is carrier. That's the answer for number 3. So when we draw the Punnett square between the Tsar and Tsarina, we have the carrier mom and we have a healthy dad. And they end up making 2 boxes of females, 2 boxes that could be males. So that's what you want to look at for numbers 5, 6, and 7. For number 5, it's asking about a child with hemophilia. There is no sex specified. Because of that, you must look at all 4 of the boxes. Only one of the boxes is fully recessive. It's this one right here. And so therefore only 1 out of 4 would result in hemophilia. That's 25%. However, for number 6, I said son. Son specifies male. So you can only look at the boxes that have XY. There are only 2 boxes that are XY. Of these 2 boxes, only 1 is fully recessive and would show the disease. So therefore, this would be 1 out of 2 or 50%. For number 7, I'm asking about a daughter. A daughter specifies female, so you can only look at the boxes that are XX. There are only 2 boxes that are XX. Of these 2, only 1 shows the carrier status of having a dominant and recessive. Therefore, it would be 1 out of these 2 boxes, which is 50%. For number 8, why did Alexi have a greater chance of getting this? Because males are the ones who get these traits more often. They only have 1 X chromosome. That means that they have kind of a 50-50 shot of whether or not they get a dominant or recessive on this X chromosome. Females can get sex-linked traits, but they have to inherit 2 recessive copies, 1 on each X, so it's much, much rarer. The term for this, for having only 1 X and therefore having a higher chance of getting these traits, is called hemizygous. So please make sure that you are aware of this term because it might show up on your midterm. If you need any further explanation or assistance, just reach out to me. Hope this helps.